Okay, so on this one, we have a function, and they're asking us about the critical numbers. What does that mean? Well, critical places is where the first derivative is zero or plus or minus infinity, either one. So let's take the first derivative. How do we take the derivative? What is this going to be? Product rule, isn't it? Product, because it's two functions multiplied. They take turns. Derivative of the first one, that's just going to be 3, right? Because the 1 power comes down, subtract 1's gone, 5 is just 0, times the second function. Oops. Oh, there we go. Unchanged. Unchanged. Plus the first function unchanged is not his turn now, times the derivative of the second function. Derivative of the second function because his turn. How do you do the derivative of e to anything? Well, remember, he's our favorite derivative, right? E to anything. E's our favorite derivative. Why? Because he does nothing. So he just stays e to the 4x. But then, because the inside was not a simple x, the chain rule says, don't forget about me. You got to take derivative of the inside. What's inside 4x? Derivative of 4x, it's 4. So there's the derivative. Don't forget that last little chain rule. A lot of people forget that last little 4. Again, how do we do the derivative of e to anything? He's our favorite one. He does nothing. But if the inside was just a simple x, we'd be done. But if the inside is anything other than a simple x, we have to do the chain rule, which is the derivative of the inside. Derivative of 4x is 4. Okay. And now what? Well, we want to know, where does this thing equal 0 or infinity? Well, let's set it equal to 0 and find out, how can we get it equal to 0? How can we do that? It's kind of a tricky little question. Here it is. Here's how you should look at it. Let me help you. If you visualize it right, it'll be good. You should see this and all of this as two separate terms. Why? Because the pluses and the minuses are what separate one term from the other. So there's the separator, which means this is the first term, and this whole thing here is the second term. So there's two terms. Okay, great, I see it. So what? Well, then that, if you're looking at it that way, what you're going to see is they both have that e to the 4x. See how they both have that in common? And when two terms have something in common, what do? We put it in the front. I'm going to use a bracket. You don't have to. You can just use a parenthesis, but brackets are nice every now and then. There's no brackets are just fancy parentheses. No difference in meaning. What? And then put a plus sign in here. What's left inside? Just ask yourself, e to the 4x times what? We'll go back to this. Well, just 3. And then e to the 4x times what? 3 there times what? We'll go back to all of this. Well, I'm going to put the 4 in the front and the 3x plus 5. All right? Got the 4, got the 3x plus 5, and then when the e to the 4x hits it, boom, we're back to that. Okay, great, I see it. So what? Okay, now keep that e to the 4x out in the front. And then let's distribute here. So we get 3 plus 12x plus 20, right? Just did a little distribution there. So let's continue to keep that e to the 4x outside and clean up the inside. What do we got on the inside? 3 and 20. Let's put the 12x was 12x plus 23 equals 0. Okay. So we're down to this point, right? We cleaned up that inside. So what? Well, how do you handle? Do you remember? How do you handle it when you've got two things multiplying? Right, you could use parentheses there. Same thing, parentheses, brackets, whatever. Multiplying to equal 0. How can two things multiply? Think about numbers. What if I told you, hey, I'm thinking of two numbers. One number multiplied by the other number, and the answer comes out 0. How could that be? How can you multiply two numbers and get an answer of 0? Well, the first one could be 0, like 0 times 7 or anything is going to come out 0. Or the second one could be 0, like -3 times 0 will also come out 0. So if the first one is 0, they'll multiply to be 0. Or if the second one is 0, they'll multiply to 0. That's the only way you're going to multiply two things and get 0 is if one or the other is 0. So we're saying, oh, so that means the first one could be 0, or the second one could be 0, right? That's just logical, right? If two things are multiplying to equal 0, First one could be zero or the second one could be zero. Let's how about this one? How can e to the 4x be zero? Well, you can take your calculator and try putting in different x's. You put in positive numbers like positive 1, positive 2, whatever. It's not going to be zero. Because remember, e's a number. E's like 2.71828, blah, 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 blah. So how can a number like 2 something to a power come out zero? It can't. Even if you put in names, they went to, even if you put in zero, you think, well, no, zero, no, what's e to the zero power? One, not doesn't equal zero. It's one. It'll never happen. There's nothing you could ever plug in up here for x. Positives, negatives, zeros that would ever make e, which is 2.71828, blah, 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 e to some power come out zero. There's no way e, which is two something, to some power is ever going to be zero. If you make the power zero, e to the zero is one. It's not zero. Anything to the zero power is one. There's no way to make that zero. So this is a dead end straight. So there's nothing here. There's no way. There's no x value. How about I say that? No x value can make this part true. There's no x value that you could ever plug in right there to make e to the 4 times x equals 0. It's impossible. Okay, well, how about over here? Over here, we can do stuff, though. Over here, we can solve for x, right? So we get 12x is minus 23 by 12. So there's an x value that will make the right side 0. And if you make the right side 0, anything times 0 will be 0. So there it is. There's our value. You can make it a decimal if you want, but that's basically the answer they got right there. You can do it on your calculator. You can just type it in that way. And so there we go. So recapping, what did we do? We took the original function and they said, find the critical values. How do you find critical numbers? Critical numbers, critical numbers are where the derivative is 0 or infinity, but there's no way to make it infinity. So it's just a matter of taking the derivative and set it equal to 0. So I took this function, I took its derivative using the product rule, rid of the first, second unchanged, first unchanged, rid of the second. That was tricky. Watch out for the chain rule equals 0. Why? Because that's what it means. The critical value is where the first derivative equals 0. So I did that and I noticed, oh, these two terms separated by the plus sign, they both have e to the 4x, e to the 4x. Factored it out, left this inside, cleaned up the inside, and said, okay, now, if these two things are multiplying to equal 0, either the first one could be 0 or the second one could be 0. This one, there's no x value that can make that happen. It's impossible. But on the other side, I can solve for x, and there's my x value that will make that happen. That's the only critical value. There we go.